Beneath the frozen crusts of distant worlds, scientists suspect entire oceans exist. Immense reservoirs of liquid water, hidden under miles of ice and rock. These are not surface seas warmed by sunlight, but secret abysses insulated from the void. Their surfaces never touched by air. Their depths never lit by stars. The concept alone unsettles our understanding of habitability. Planets and moons we once thought lifeless may, in truth, be vaults of liquid concealment. When NASA's Galileo spacecraft orbited Jupiter in the 1990s, it detected anomalies in the planet's magnetic environment that hinted at conductive materials beneath the icy shells of moons like Europa. Conductive, in astrophysical terms, meant salt water, and not in puddles or small reservoirs, but in oceans larger than anything on Earth. A hidden ocean of such scale alters the boundary between what we consider barren rock and what we consider capable of nurturing life. If water is the foundation, then life's absence becomes a matter of probability, not possibility. For psychologists and neuroscientists, such discoveries resonate in a different register. The ocean locked inside a planet is an image of the unconscious. Vast, unlit, but filled with potential activity. Carl Jung often described the unconscious mind as an abyss beneath the fragile crust of consciousness, an inner sea where archetypes, drives, and symbols reside. Just as sunlight cannot reach Europa's ocean, conscious reflection cannot always penetrate the deeper strata of mind. Yet the turbulence below influences the surface above, shaping behavior, perception, and even culture. This parallel is not merely poetic. It reflects a truth about hidden systems sustaining visible order. In planetary science, the question is not only whether these oceans exist, but how they stay liquid in the freezing dark. In psychology, the question mirrors it. How can unconscious drives remain active without conscious light? Theories of implicit memory, priming, and subliminal influence demonstrate that even when hidden, these layers of mind retain motion, capable of shaping choices that feel autonomous. Both in planets and in people, unseen depths carry immense force. The unsettling realization is that life itself may not require the visible surface. Just as human cognition can be guided by unseen biases and silent impulses, biological processes elsewhere may thrive without exposure to starlight. The hydrothermal vents of Earth's deep oceans prove this principle. Entire ecosystems exist independent of the sun, nourished by chemical reactions and heat from the planet's core. If such autonomy is possible here, then the frozen moons orbiting giants like Jupiter and Saturn may already hold entire shadow ecologies, waiting beneath their shells. The thought draws us toward a haunting possibility, what we call the habitable zone, the comfortable band around a star where liquid water can exist on a planet as surface, may be an illusion of perspective. If water can persist in the cold dark, shielded by ice and maintained by pressure, then the galaxy could be saturated with secret oceans. The boundaries of life are wider, stranger, and more concealed than we imagined. Just as hypnosis, meditation, and sensory deprivation can unlock hidden patterns in the human mind, space exploration now seeks to pierce the icy crusts of alien worlds to reveal what lies submerged. Both journeys imply that what is hidden is not inert. It is alive, dynamic, and perhaps far more influential than the visible surface. You are invited in this series to descend into those hidden seas, not only in distant planets, but in the metaphors they awaken inside us. Stay with the current and notice how the boundary between science and psyche grows thin when one contemplates oceans that should not exist, yet do. The crust is only the beginning. Beneath it, the water waits. Beneath the frozen crusts of distant worlds, scientists suspect entire oceans exist. Immense reservoirs of liquid water, hidden under miles of ice and rock. These are not surface seas warmed by sunlight, but secret abysses insulated from the void. Their surfaces never touched by air. Their depths never lit by stars. The concept alone unsettles our understanding of habitability. Planets and moons we once thought lifeless may, in truth, be vaults of liquid concealment. When NASA's Galileo spacecraft orbited Jupiter in the 1990s, it detected anomalies in the planet's magnetic environment that hinted at conductive materials beneath the icy shells of moons like Europa. Conductive, in astrophysical terms, meant salt water, and not in puddles or small reservoirs, but in oceans larger than anything on Earth. A hidden ocean of such scale alters the boundary between what we consider barren rock and what we consider capable of nurturing life. If water is the foundation, then life's absence becomes a matter of probability, not possibility. For psychologists and neuroscientists, such discoveries resonate in a different register. The ocean locked inside a planet is an image of the unconscious. Vast, unlit, but filled with potential activity. Carl Jung often described the unconscious mind as an abyss beneath the fragile crust of consciousness, an inner sea where archetypes, drives, and symbols reside. Just as sunlight cannot reach Europa's ocean, conscious reflection cannot always penetrate the deeper strata of mind. Yet the turbulence below influences the surface above, shaping behavior, perception, and even culture. This parallel is not merely poetic. It reflects a truth about hidden systems sustaining visible order. In planetary science, the question is not only whether these oceans exist, but how they stay liquid in the freezing dark. In psychology, the question mirrors it. How can unconscious drives remain active without conscious light? Theories of implicit memory, priming, and subliminal influence demonstrate that even when hidden, these layers of mind retain motion, capable of shaping choices that feel autonomous. Both in planets and in people, unseen depths carry immense force. The unsettling realization is that life itself may not require the visible surface. Just as human cognition can be guided by unseen biases and silent impulses, biological processes elsewhere may thrive without exposure to starlight. The hydrothermal vents of Earth's deep oceans prove this principle. Entire ecosystems exist independent of the sun, nourished by chemical reactions and heat from the planet's core. If such autonomy is possible here, then the frozen moons orbiting giants like Jupiter and Saturn may already hold entire shadow ecologies, waiting beneath their shells. The thought draws us toward a haunting possibility, what we call the habitable zone, the comfortable band around a star where liquid water can exist on a planet's surface, may be an illusion of perspective. If water can persist in the cold dark, shielded by ice and maintained by pressure, then the galaxy could be saturated with secret oceans. The boundaries of life are wider, stranger, and more concealed than we imagined. Just as hypnosis, meditation, and sensory deprivation can unlock hidden patterns in the human mind, space exploration now seeks to pierce the icy crusts of alien worlds to reveal what lies submerged. Both journeys imply that what is hidden is not inert. It is alive, dynamic, and perhaps far more influential than the visible surface. You are invited in this series to descend into those hidden seas, not only in distant planets, but in the metaphors they awaken inside us. Stay with the current and notice how the boundary between science and psyche grows thin when one contemplates oceans that should not exist, yet do. The crust is only the beginning. Beneath it, the water waits,
When astronomers speak of hidden seas, Europa is the archetype. Slightly smaller than Earth's moon, Europa circles Jupiter in a world of radiation storms and gravitational extremes. Its surface, captured in detail by Voyager and Galileo, is unlike any other, a smooth shell of ice etched with dark fractures, chaotic blocks, and ridges that span thousands of kilometers. Unlike the craters of airless moons, Europa's crust looks restless, as if floating upon something mobile beneath. Galileo's magnetometer provided the first decisive clue. In 1998, the spacecraft recorded perturbations in Jupiter's vast magnetic field as it passed Europa. These deviations were consistent with the presence of a conductive layer beneath the surface. The only plausible candidate was a global saltwater ocean, hundreds of kilometers deep, capable of carrying electrical currents. Models suggested that Europa may hold twice the volume of all Earth's oceans combined, locked beneath an icy ceiling perhaps 20 kilometers thick. This discovery shifted Europa from an obscure moon to a focal point of astrobiology. If life could exist without sunlight, hidden beneath a shell of ice, Europa represented the most accessible laboratory for testing that idea. The surface fractures visible in images hinted at convection, warm ice rising, cold ice sinking, perhaps even partial melting that allows material to exchange between surface and ocean. Such dynamics would not only maintain the liquid state, but could also supply chemical gradients necessary for metabolism. The psychological effect of contemplating Europa is profound. It presents a paradox of silence and activity, a world that looks frozen yet may conceal turbulence on a planetary scale. Neuroscience offers a strange resonance here. In functional imaging studies, the human brain at rest appears quiet, but networks such as the default mode reveal immense underlying activity. The surface of conscious awareness may appear calm, while beneath it, associations, memories, and self-referential processes churn. Europa's crust is like consciousness itself, static in appearance, concealing a dynamic sea of currents beneath. Geological analogues on Earth help scientists frame these possibilities. Beneath Antarctica's ice, Lake Vostok has remained sealed for millions of years under 4 kilometers of frozen crust. Despite the isolation, radar surveys and chemical analyses suggest microbial life may persist there, nourished by geothermal heating and mineral inputs from the bedrock. Europa's ocean would dwarf Lake Vostok in scale, but the principle is parallel. Isolation does not preclude activity, and darkness does not forbid vitality. The cracks and ridges on Europa also suggest episodes of exchange. Some regions appear as if surface ice has broken, rotated, and refrozen, implying movement atop a liquid foundation. In other areas, deposits of reddish-brown material mark places where subsurface water may have erupted onto the surface and frozen in place. Spectroscopic analysis indicates the presence of salts and possibly organic molecules within these deposits. The ocean beneath is not chemically pure. It is complex, perhaps enriched with the building blocks of biochemistry. Europa's environment introduces the concept of tidal heating, a process vital for understanding how liquid water persists so far from the Sun. As Europa orbits Jupiter, gravitational forces stretch and compress the Moon rhythmically. This tidal flexing generates heat in the interior, enough to maintain liquid water beneath the ice. The same force that keeps Europa locked in a gravitational dance also ensures the persistence of its inner ocean. The metaphor with human physiology is striking. Rhythmic forces, circadian cycles, heartbeat, respiration, sustain hidden processes within the body, often unnoticed until disrupted. The astrobiological implications extend further. Hydrothermal vents on Europa's seafloor, if they exist, could replicate conditions where life is thought to have originated on Earth. At such vents, chemical disequilibria between hot, mineral-rich fluids and cold seawater provide energy for chemosynthetic organisms. Experiments by Günter Wachteschoser and others demonstrated that iron-sulfur surfaces at high temperature can catalyze reactions resembling primitive metabolism. If similar processes occur within Europa, its ocean could host not only microbes but entire ecosystems thriving in perpetual night. Europa's hidden sea also challenges human concepts of exploration. Unlike Mars, where surface rovers can traverse the terrain and study exposed rock, Europa demands penetration through an icy barrier. The psychological resonance of drilling through layers to reach an unseen reservoir mirrors therapeutic techniques in psychoanalysis, where the analyst seeks to breach defenses to uncover deeper material. Both endeavors face resistance. The crust of ice resists mechanical entry, just as the human psyche resists exposure of unconscious content. Yet the promise beyond the barrier compels the attempt. There is a peculiar discomfort in recognizing how little separates us from knowing. The icy crust is not insurmountable, yet no instrument has yet pierced it. Instead, scientists rely on indirect signs, magnetic anomalies, surface fractures, geyser-like plumes possibly venting from the ocean into space. Each clue intensifies the sense that beneath the silence lies an environment waiting to be encountered. The very act of withholding, of being so close yet unreachable, enhances the psychological weight of Europa's ocean, like a memory the mind cannot retrieve but knows must be there. The closer one looks at Europa, the more the concept of an untouched, unseen ocean acquires an unsettling presence. It is no longer only a scientific hypothesis, but a reminder that vast systems may exist entirely beyond perception, influencing from beneath while never revealing themselves directly. Each model refined, each spectrographic measurement taken, leaves us with sharper questions rather than certainties. As research deepens, Europa's ocean becomes less an abstraction and more an imminent reality, a concealed domain whose scale and potential eclipse ordinary imagination, pressing against the limits of what exploration and consciousness can tolerate. Among Saturn's many moons, Enceladus is modest in size, barely 500 kilometers across, yet its diminutive scale conceals a revelation that altered the trajectory of planetary science. When the Cassini spacecraft arrived in Saturn's orbit in 2004, Enceladus presented itself as a world of bright, reflective ice, an object so small that it should have been geologically inert. Instead, Cassini recorded towering plumes erupting from the South Polar region, geysers of water vapor and ice grains blasting into space at hundreds of meters per second. Subsequent flybys confirmed that these jets originated from fissures in the icy crust, now known as the tiger stripes. Instruments on Cassini detected salts, silica particles, and complex organic molecules within the plumes. The presence of such material indicated more than surface sublimation. It pointed to liquid reservoirs beneath the crust, maintained in a dynamic state that allowed matter to escape into the vacuum. Unlike Europa, whose ocean remains concealed behind kilometers of ice, Enceladus reveals its interior directly through these vents, offering samples that can be captured without drilling. Geophysical modeling suggests that beneath the South Pole lies a global ocean tens of kilometers deep, in contact with a rocky core. The interaction between water and rock is significant, for it allows the possibility of hydrothermal activity. Laboratory experiments conducted at high pressure and temperature, simulating Enceladus' interior, demonstrate that silica nanograins form only when water percolates through hot, mineral-rich rock. Cassini's detection of such particles in the plumes is considered compelling evidence that the Moon's hidden sea is not static but geologically active, producing chemical disequilibria that could sustain metabolism. The image of plumes erupting into the void resonates psychologically with the concept of unconscious material forcing its way to the surface. In Freud's model of repression, latent drives and memories may remain submerged for long periods, but under pressure, they manifest as slips, symptoms, or dreams. Enceladus jets resemble such eruptions, involuntary disclosures of hidden processes that would otherwise remain undetected. The Moon's crust, like the human psyche, cannot contain everything indefinitely. Fractures become conduits, and what lies beneath announces itself in sudden, unbidden bursts. Beyond metaphor, the implications are biological. Terrestrial hydrothermal vents host ecosystems where organisms rely on chemosynthesis rather than photosynthesis. Bacteria and archaea metabolize hydrogen, methane, and sulfur compounds, forming the base of food webs that sustain larger creatures such as tubeworms and clams. If similar vents line the ocean floor of Enceladus, they could provide not only energy but also stability, creating oases of habitability. Experiments in extremophile biology have shown that microbes can thrive under pressures and temperatures far exceeding those expected on the seafloor of this small moon. The detection of organic molecules in the plumes deepens the intrigue. Some were simple compounds like methane and carbon dioxide, but others were more complex hydrocarbons. The discovery did not prove the existence of life, but it eliminated the need to imagine life as requiring foreign chemistry. The ingredients on Enceladus mirrored those on Earth, reducing the distance between terrestrial and extraterrestrial conditions. In psychological terms, this collapse of distance recalls the phenomenon of déjà vu, when unfamiliar experiences are perceived as strangely familiar. Enceladus is alien, yet its chemistry feels known, as if mirroring processes we already carry within our own oceans. What unsettles most is the scale of access. Unlike other hidden seas, Enceladus offers samples through its natural plumes, ejecting its secrets into interplanetary space. Cassini's instruments could measure composition directly, detecting both organic molecules and evidence of salinity. Yet even with this direct access, interpretation remains difficult. Methane, for instance, could arise from biological processes such as methanogenesis, but it could also form through abiotic reactions between water and rock. Distinguishing between the two requires precision that current instruments cannot provide. The situation resembles the interpretation of ambiguous stimuli in psychological experiments. In projective tests such as the Rorschach ink blot, individuals are asked to impose meaning upon ambiguous forms. The resulting associations are believed to reveal underlying patterns of thought. Similarly, scientists impose hypotheses upon Enceladus data, attempting to discern whether the chemistry reflects life or mere geology. The ambiguity itself is instructive. It demonstrates that evidence alone is insufficient without frameworks of interpretation, and those frameworks reveal as much about human cognition as they do about the moon. The plumes also complicate the concept of isolation. Subsurface oceans are often imagined as hermetically sealed, immune to the cosmos. Enceladus proves the opposite. Its ocean communicates with space, releasing vapor and particles that escape into Saturn's earring. In this sense, Enceladus is not fully enclosed but participates in an exchange that links hidden depths to the wider planetary system. The same principle governs the human nervous system. The unconscious is not a sealed reservoir but one that leaks into behavior, language, and perception, altering the collective environment in which individuals live. Even the brightness of Enceladus adds a symbolic dimension. The moon reflects nearly all the sunlight it receives, making it one of the most reflective bodies in the solar system. To appear so luminous while harboring a dark ocean beneath captures the duality of surface and depth, radiance concealing secrecy, visibility masking interior obscurity. The contrast unsettles not because it is alien, but because it mirrors structures we recognize in ourselves: the polished surface of consciousness, the luminous presentation to others, while within lies a hidden sea of impulses and associations. Every measurement from Cassini tightened the case for an active ocean, yet none dispelled the uncertainties. Each flyby raised further questions about salinity, pressure, heat, and chemistry. The very abundance of data amplified the unresolved, leaving scientists with sharper paradoxes rather than clarity. Enceladus, though small, carries disproportionate weight in astrobiology, reminding us that size and scale do not determine significance when hidden processes are at play. The moon continues to cast a shadow across exploration and psychology alike, for its eruptions are both literal and symbolic. signals from a place where the interior cannot remain silent, and where what escapes may be only a fragment of what stirs beneath. If Europa and Enceladus represent striking revelations, Ganymede and Callisto introduce a different kind of mystery, one that lies in scale and stratification. Both moons belong to Jupiter's domain, but their hidden oceans are not confined to simple cavities beneath ice. Instead, geophysical models suggest layered worlds, with multiple strata of ice and water stacked like a colossal palimpsest, each boundary shaped by pressure, phase transitions, and mineral content. Ganymede, the largest moon in the solar system, surpasses even Mercury in size. It possesses its own magnetic field, a rare attribute among moons, detected by Galileo in 1996. The existence of this field implies an internal dynamo, generated by motion in a conductive fluid layer deep within. Beneath the surface, modeling predicts an ice shell tens of kilometers thick, underlain by an ocean perhaps 100 kilometers deep. But unlike Europa's presumed single ocean, Ganymede may contain alternating layers of liquid water and exotic high-pressure ices. These polymorphs, such as Ice V, 6, and 7, form under immense pressures, each denser than liquid water. The result is an inverted architecture, a liquid layer, trapped between solid phases, deprived of direct contact with the rocky mantle. This configuration complicates the astrobiological picture. On Earth, life thrives at the interface between water and rock, where minerals and heat catalyze chemistry. In Ganymede's case, the lower boundary of the ocean may not be rock at all but high-pressure ice, reducing the potential for geochemical energy. Yet the possibility of multiple liquid layers introduces another dimension. Each could possess distinct chemical compositions, temperatures, and circulation patterns. The metaphor is less of a single ocean and more of a stacked unconscious, with layers of memory and drive sealed off from each other, yet influencing the system as a whole. Callisto, further from Jupiter, lacks Ganymede's internal dynamo, but presents an equally intriguing structure. It is heavily cratered, with a surface that has remained geologically quiet for billions of years. Yet beneath that ancient crust, magnetic measurements and gravity data suggest the presence of a buried ocean. Like Ganymede, Callisto's ocean may be interleaved with ice layers, stabilized by the presence of ammonia, which lowers the freezing point of water. Ammonia-water mixtures are familiar in planetary science as antifreeze solutions, enabling liquid phases to persist under conditions that would otherwise enforce solidity. The presence of such chemistry hints at an ocean that is both alien and plausible, suspended in darkness yet stabilized by molecular adaptations. In psychological terms, the stratified structure of these moons resonates with theories of layered consciousness. Sigmund Freud distinguished between the conscious, the preconscious, and the unconscious, while later models by cognitive psychologists introduced further divisions, such as procedural versus declarative memory. Each layer operates under different principles, often isolated yet not inert. Just as procedural memory enables a person to ride a bicycle without conscious recall of each movement, a buried ocean beneath layers of ice may sustain processes independent of surface expression. The compartmentalization is not dysfunction but structure, a way of sustaining complexity by separating domains. The physical reality of layered oceans demands an unfamiliar way of imagining habitability. Instead of picturing sunlight filtering through water, one must imagine chemical gradients operating within boundaries of pressure-stabilized ice. The interface between layers becomes the site of activity, just as the synapse in the brain becomes the site of communication between neurons. In both systems, the boundary is not a limit but an active zone, where gradients generate flow, and flow generates change. Historical precedents also reflect this fascination with layered depths. In medieval cosmology, the universe was depicted as concentric spheres, each enclosing the next, extending outward from Earth to the fixed stars. The pattern of containment within containment mirrored a psychological intuition, that hidden within each domain lies another, subtler one, less visible but equally real. The geophysical models of Ganymede and Callisto render this intuition literal, demonstrating that stratification is not only symbolic but physically realized in planetary interiors. The presence of multiple oceans within a single moon also raises the possibility of compartmentalized ecosystems, each isolated from the others, evolving along divergent trajectories. Biologists studying isolated lakes in Antarctica have noted how separation fosters distinct microbial populations, adapted uniquely to local conditions. If similar isolation occurs within layered oceans, then a single moon might host not one biosphere but several, hidden from each other by pressure-stabilized barriers. The idea destabilizes the anthropocentric assumption of a unified environment. Instead, habitability may be fragmented, partitioned into silent chambers, each with its own rules. The uncertainty surrounding these structures is intensified by the scarcity of direct data. Unlike Enceladus, which vents its secrets into space, Ganymede and Callisto remain sealed. Evidence comes only from magnetometers, gravitational harmonics, and theoretical modeling. The reliance on indirect inference recalls the challenge of studying the unconscious. The analyst never observes it directly, but interprets traces, slips, and resistances. Similarly, planetary scientists build pictures of stratified oceans from perturbations in orbital paths or subtle deviations in magnetic lines. What emerges is not a portrait but a silhouette, a pattern inferred from shadows. The silence of Callisto, in particular, unsettles. While Ganymede shows evidence of geological activity in its past, Callisto appears frozen in time, a surface unrenewed for billions of years. Yet beneath that quiet exterior may lie a restless ocean, as hidden as it is ancient. The dissonance between surface stillness and possible interior motion captures a familiar psychological theme. The individual who appears unchanging, predictable, even inert, yet carries within a dynamic reservoir of unexpressed forces. Just as Callisto's pockmarked face belies the possibility of a liquid sea, so too the human demeanor can conceal complexity that resists surface interpretation. As missions prepare to return to the Jovian system, most notably ESA's Jupiter Icy Moons Explorer, JUICE, instruments will attempt to probe these stratified worlds with unprecedented resolution. Radar sounding, magnetometer readings, and spectroscopic surveys may refine the models of their interiors. Yet even the most advanced tools will only graze the surface of certainty, leaving the deeper configuration obscured, layered in mystery as much as in ice. The vastness of Ganymede and the silence of Callisto both lead toward an unresolved question: whether oceans divided by pressure and partitioned by ice can sustain more than liquid water, whether they can sustain systems that move, change, and perhaps even persist in ways not yet conceived. Titan, Saturn's largest moon, presents a paradox more intricate than any other body in the outer solar system. On its surface lies a world that is not merely icy but meteorologically active, with clouds, rain, rivers, lakes, and seas. Unlike Earth, these bodies of liquid are not water but hydrocarbons, methane and ethane, flowing across plains and filling basins in a cycle powered by weak sunlight and atmospheric chemistry. Beneath this alien hydrological system, however, geophysical data indicate the presence of another, deeper layer, a hidden ocean of liquid water mixed with ammonia, concealed below an ice shell and interacting with Titan's interior in ways that remain elusive. Radar measurements from the Cassini mission mapped Titan's surface with remarkable precision, revealing lakes in the polar regions and dune fields encircling the equator. Yet gravity data and models of tidal response suggested something less visible. Titan's outer shell deforms under Saturn's pull in a way consistent with a global subsurface ocean. This ocean is likely hundreds of kilometers deep, sandwiched between a thick icy crust and a silicate core. The mixture of water and ammonia depresses the freezing point, maintaining liquid conditions despite surface temperatures near -180 degrees Celsius. The complexity of Titan's dual systems, hydrocarbon seas above, aqueous ocean below, makes it a layered enigma. On the surface, methane cycles mimic Earth's hydrology, complete with evaporation, cloud formation, rainfall, and erosion. Beneath, a concealed ocean circulates with no direct connection to the surface. The juxtaposition invites comparison with the layered architecture of human cognition. Cognitive neuroscience distinguishes between online processes accessible to conscious reflection and offline processes that operate beneath awareness. Titan mirrors this structure, an outward cycle observable to telescopes, and an inward cycle hidden, detectable only through indirect measurements. The psychological resonance deepens when considering Titan's atmosphere. It is dense, with a pressure 1.5 times that of Earth's sea level, filled with nitrogen and hydrocarbons that shroud the surface in haze. This obscuring veil has long denied direct observation, concealing the moon beneath an orange blur. Before Cassini's radar pierced the haze, Titan was imagined largely through inference, an object always seen through obscurity. The situation is analogous to the ways in which memory or trauma becomes inaccessible, veiled by distortions that prevent clear perception. The haze is not absence but barrier, transforming what lies below into an object of speculation. What distinguishes Titan from other ocean worlds is the simultaneous presence of organic chemistry on its surface. Spectroscopic analysis has revealed complex molecules in its atmosphere, formed by photochemical reactions driven by ultraviolet radiation from the Sun and energetic particles from Saturn's magnetosphere. These molecules, including tholins, precipitate onto the surface, coating the dunes and lakes with a tar-like substance. In origin of life studies, such organics are considered prebiotic, capable of combining into more elaborate structures under the right conditions. Titan therefore hosts the raw materials for biology both above and below, yet in contexts that defy Earth-based expectations. The duality of Titan's environments recalls the concept of dissociation in psychology. Dissociation involves the compartmentalization of experience, where parts of the mind operate independently of others, creating discontinuities in perception or memory. On Titan, the hydrocarbon world of the surface and the aqueous world of the subsurface are compartmentalized, operating under separate chemistries. Each is coherent within itself but detached from the other, an estranged duality within a single body. Whether these domains ever interact remains an open question. If fractures or cryovolcanic eruptions connect them, the mixing of hydrocarbons and water could catalyze unprecedented chemical pathways, collapsing the separation into synthesis. Evidence of cryovolcanism on Titan remains debated. Some surface features, interpreted from radar images, resemble domes or flows that could indicate eruptions of water-ammonia slurries. If confirmed, such processes would demonstrate that Titan's hidden ocean occasionally breaches its icy ceiling, delivering material to the surface and perhaps mixing with the hydrocarbon lakes. The psychological parallel is the eruption of repressed material into consciousness, unpredictable yet transformative, collapsing barriers between compartments and forcing integration of incompatible domains. The habitability of Titan's hidden ocean hinges on its interaction with the rocky core. If the ocean is in contact with silicate rock, geochemical reactions could supply energy sources similar to those sustaining extremophiles on Earth. Serpentinization, the alteration of rock by water, producing hydrogen and heat, is one plausible mechanism. The presence of ammonia complicates this chemistry, but it also stabilizes liquid phases, extending the lifetime of the ocean. The tension between stabilizing and inhibiting effects is mirrored in the brain's neurochemistry, where compounds can simultaneously enable and constrain neural signaling, maintaining balance in a system always poised between activity and stasis. The symbolic weight of Titan lies in its inversion of the familiar. On Earth, water flows on the surface and hydrocarbons remain buried. On Titan, hydrocarbons flow above, while water is buried beneath. This reversal unsettles perception, not because it is chaotic, but because it is orderly in a way foreign to expectation. The mind resists inversion, yet inversion forces reconsideration of what is essential. In Titan's case, the recognition that life's ingredients may assemble in conditions so reversed destabilizes the narrow anthropocentric template of habitability. Cassini's legacy left Titan as a body of contradictions, a moon that resembles Earth yet defies its principles, a world that is both veiled and expressive, compartmentalized yet possibly connected. The deeper ocean remains unmeasured, a hidden volume implied by tides but unpenetrated by any probe. The questions it raises are not limited to chemistry or biology. They press against broader categories of perception, concealment, and duality. The longer Titan remains unexamined beneath its crust, the stronger the sense grows that its dual systems may not simply coexist but influence one another in ways yet unseen. The weight of this unresolved interaction compels attention, suggesting that beneath the layers of haze, hydrocarbons, and ice, the forces at work may be converging toward phenomena we cannot yet define. Far beyond Saturn, orbiting the distant giant Neptune, lies Triton, a moon whose very existence defies the expectations of planetary order. Unlike most large satellites, which coalesce from the disks of gas and debris surrounding their planets, Triton moves in a retrograde orbit, circling Neptune in the opposite direction of the planet's rotation. This unusual trajectory reveals its likely origin. Triton was not born with Neptune but captured, probably from the Kuiper Belt, a region of icy bodies beyond Pluto. The violence of such a capture would have altered both Triton and Neptune, stripping away other satellites, reshaping orbits, and generating immense tidal heat inside the Moon. That heat, combined with radioactive decay, may have melted much of Triton's interior, leaving behind the possibility of a concealed ocean that persists beneath its surface to this day. Voyager 2, which flew past Neptune in 1989, remains the only spacecraft to have observed Triton directly. Its cameras revealed a surface both alien and familiar: plains of nitrogen ice, cantaloupe-like terrain of enigmatic texture, and geysers erupting columns of gas and dust several kilometers into space. These plumes suggested internal activity, driven not by solar warmth but by energy stored within. In a world so far from the Sun, where surface temperatures hover near -235 degrees Celsius, any expression of motion implies a hidden reservoir of heat, and by extension, the possibility of liquid phases concealed beneath the crust. The stability of Triton's interior has been modeled with increasing sophistication since Voyager's brief encounter. Computer simulations indicate that the residual heat from its violent capture, combined with ongoing tidal flexing as its retrograde orbit slowly decays, could sustain a liquid layer between the outer ice shell and the rocky core. The inclusion of antifreeze compounds such as ammonia or salts would extend the longevity of such an ocean, preventing it from freezing solid across geological timescales. The likely depth of this ocean is measured not in small reservoirs but in global proportions, comparable in volume to terrestrial seas. What unsettles is the recognition that Triton, though remote and barely studied, might embody processes that blur categories of planetary identity. It is simultaneously a captured Kuiper Belt object, a moon with geological activity, and a possible ocean world. Psychologically, it mirrors the phenomenon of dislocation in identity, a part of the psyche uprooted from its origin and forced into a new orbit, generating turbulence that reverberates internally. Just as Triton was torn from its original context and bound to Neptune, aspects of human identity may be captured by external forces, reshaped into patterns that carry hidden reservoirs of tension. The geysers recorded by Voyager hint at shallow processes, possibly driven by seasonal heating of nitrogen ice. Yet they also raise the question of deeper dynamics. If surface layers can channel eruptions into space, might fractures extend into subsurface reservoirs, linking surface activity with concealed oceans? The thought echoes psychological models of repression and expression. Material buried deep within may find narrow channels to the surface, manifesting not in its entirety but in fragments, enough to signal the presence of hidden forces, but insufficient to disclose them fully. Triton's retrograde orbit adds another layer of instability. Over tens of millions of years, gravitational interactions with Neptune are expected to bring the Moon gradually closer. Eventually, tidal forces may tear it apart, forming a ring system before it is lost entirely. This fate emphasizes the transient nature of Triton's current condition. If a subsurface ocean exists, it exists within a body destined for eventual disintegration. The analogy to human temporality is striking. Systems of depth and vitality may flourish even as the larger framework moves inexorably toward dissolution. Awareness of this tension imbues Triton with an uncanny sense of mortality at a planetary scale. From an astrobiological perspective, Triton offers a natural experiment distinct from Europa or Enceladus. Its origin in the Kuiper belt suggests it formed with a different inventory of volatiles, perhaps richer in organics. If these compounds survived capture and mingled with subsurface water, Triton's ocean could be chemically fertile, providing conditions unlike those within Jupiter's or Saturn's systems. The possibility that such an environment exists but remains sealed beneath kilometers of ice captures the imagination with the same disquiet as the unconscious, a system known by inference, concealed by distance and opacity, yet capable of influencing the surrounding environment through subtle emissions. Voyager's data remain fragmentary, but they evoke a moon alive in ways inconsistent with its remoteness. Its cantaloupe terrain may record processes of upwelling and resurfacing. Its plumes demonstrate a link between interior heat and surface change. Its orbit guarantees ongoing stress, flexing the crust and sustaining motion. These features converge toward a picture in which stillness is only apparent, beneath which lies a shifting, fluid realm. The psychological resonance is unavoidable. The facade of cold and distance masking inner motion, the surface of composure concealing reservoirs of energy, the inevitability of forces pressing upward despite layers of suppression. Triton also occupies a threshold position in human perception. Unlike Europa or Titan, it has been glimpsed only briefly, through a single mission. Its image is thus fixed in cultural memory as a snapshot, incomplete and unresolved. In psychology, unintegrated experiences, those touched only once, never revisited, linger as fragments, shaping thought indirectly. Triton remains such a fragment for planetary science, its features frozen in partial knowledge, a reminder that vast complexity may reside in what is only half seen. As Neptune itself remains unexplored since Voyager's passage, Triton hangs in uncertainty, its ocean hypothesized but unconfirmed, its activity glimpsed but not explained. The combination of capture, instability, and concealment imbues it with an unresolved tension, leaving open the question of how long such a hidden sea can endure, and what transformations it may undergo before the Moon is drawn inexorably closer to its giant master. When New Horizons swept past Pluto in July 2015, expectations were modest. The dwarf planet had long been imagined as a frozen relic, a static shard of the Kuiper belt, too small and too distant to harbor geological vitality. What the spacecraft revealed instead was a surface young, fractured, and unexpectedly dynamic. Towering mountains of water ice rose above vast plains of nitrogen frost, and in the center of Sputnik Planitia stretched a basin that appeared not ancient but active, its polygonal cells indicating convection within. Such activity implied heat, and with heat came the possibility of liquid water concealed beneath. Geophysical analysis of Pluto's surface suggested that Sputnik Planitia formed as an impact basin later filled with volatile ices. Its present alignment with Pluto's tidal axis indicates that the basin is underlain by a mass anomaly, likely an ocean maintained in a liquid state by residual heat and antifreeze compounds. Models show that if Pluto's interior were entirely solid, the basin would have collapsed, creating compressional features at its margins. Instead, evidence of extensional tectonics dominates, consistent with global expansion as water froze and expanded at depth. The implication is that an ocean once existed and may persist still, trapped beneath a shell of ice. The existence of a hidden ocean on Pluto unsettles assumptions about habitability. At 40 astronomical units from the Sun, surface temperatures average near -230 degrees Celsius. Any liquid state must be insulated, stabilized, and maintained by processes independent of solar input. The presence of such an ocean demonstrates that planetary activity is not confined to the warmth of inner systems, but can arise in the deep cold, where isolation is compensated by insulation and chemistry. In human psychology, the analogy lies in the persistence of inner life beneath conditions of external deprivation. Even when environments appear barren, unseen processes can continue, fueled by internal reserves rather than outward nourishment. The composition of Pluto's hidden sea remains speculative. Ammonia, detected in surface deposits, likely plays a role, lowering the freezing point of water and extending the lifespan of liquid phases. Salts may contribute further, altering density and circulation. If such a mixture exists, it would be more akin to a brine than to terrestrial seawater, a solvent capable of complex chemistry yet alien to direct comparison. The thought evokes the phenomenon of altered states of consciousness, where ordinary processes are transformed by the introduction of chemical modifiers, producing conditions unfamiliar yet coherent in their own logic. Beyond chemistry, Pluto's ocean raises questions about time. How long can such a reservoir persist? Thermal models indicate that if the ocean formed early, radioactive isotopes within Pluto's rocky core could sustain liquid water for billions of years. As those isotopes decay, the ocean may gradually freeze, but the process is slow, leaving a present that is neither wholly liquid nor wholly solid. This liminality resonates with psychological states that are neither one condition nor another, suspended in tension. Just as Pluto's ocean may linger between phases, human consciousness often hovers between clarity and opacity, stability and dissolution. Pluto also challenges perception through its surface expressions of what lies beneath. The tectonic features mapped by New Horizons, vast troughs and scarps stretching for hundreds of kilometers, indicate stresses imposed from below. Expansion fractures mark the crust like scars, evidence of pressure from a subsurface ocean that has partially frozen and forced the surface to yield. The metaphor is immediate. Hidden pressures manifest in surface ruptures, not random but patterned, betraying the dynamics within. In this sense, Pluto's geology mirrors the way suppressed psychological forces eventually distort outward behavior, inscribing traces of interior conditions onto visible form. The broader context of the Kuiper belt amplifies the significance. Pluto is not alone but one of countless icy bodies orbiting beyond Neptune, many of comparable size. If Pluto conceals an ocean, it is plausible that others do as well. Eris, Makemake, Haumea, and numerous smaller objects, each with its own history of heat, composition, and structure. The prospect suggests a vast population of ocean worlds beyond the classical planets, hidden not only beneath ice but within distance itself, their very remoteness shielding them from observation. The psychological parallel is that of repressed collectives, entire domains of experience unacknowledged yet structurally present, shaping the totality of the system while remaining unseen. New Horizons' fleeting encounter left Pluto in partial disclosure. High-resolution images covered only one hemisphere, leaving the far side in lower detail. Gravity data sufficient to confirm or deny an ocean could not be obtained. The result is a world half revealed, half concealed, suspended between knowledge and ignorance. This asymmetry resembles the limits of introspection. What is brought into awareness illuminates one side, while the other remains in shadow, exerting influence without exposure. The incomplete nature of our view enhances rather than diminishes the tension, leaving open the possibility that the unseen side conceals features as startling as those already discovered. In cultural memory, Pluto carries symbolic weight as a body demoted from planetary status, relegated to dwarf classification after the 2006 redefinition. Yet the revelations of New Horizons invert the demotion. Rather than diminished, Pluto appears enriched, transformed from a marginal remnant into a site of profound geological and possibly hydrological complexity. The reclassification echoes psychological processes of projection and devaluation. What is cast out or dismissed often conceals greater depth than acknowledged, and only when re-examined does its significance emerge. The recognition that Pluto may harbor a liquid sea beneath its frozen shell shifts the frontier of exploration outward. No longer can the Kuiper Belt be considered a realm of inert debris. Each object may carry within it a history of heat and water, a hidden archive of processes capable of sustaining more than inert matter. As the inventory of such bodies grows, the realization takes hold that the architecture of the solar system is richer and stranger than once conceived, with habitability not confined to favored zones but dispersed across distances where light barely reaches. The open question remains how many of these distant objects contain oceans, how long those oceans endure, and whether their chemistry crosses the threshold from solvent to system, from material to metabolism. The uncertainty extends outward, hinting that what lies beyond Pluto may not be a void but a vast archipelago of concealed seas, each silently sustaining conditions that have yet to be encountered. The discovery of oceans within the solar system has transformed expectations for what may exist beyond it. When astronomers detect exoplanets circling distant stars, they do not merely speculate about atmospheres and surfaces. They now consider the possibility of concealed oceans beneath ice or rock. The search for water has shifted from the visible to the invisible, from oceans lit by sunlight to those buried in darkness, hidden beneath kilometers of crust. The evidence for such hidden seas lies not in direct observation but in inference, built from transit curves, density estimates, and atmospheric spectra. Planets and moons beyond the solar system display a bewildering variety. Among the most intriguing are water worlds, planets with densities lower than rock but higher than gas, suggesting large fractions of water or volatiles. Modeling of these bodies indicates that many may not resemble Earth with surface oceans, but rather possess global layers of water capped by ice or high-pressure phases. In such worlds, liquid water could exist in thick mantles hundreds of kilometers deep, overlain by exotic polymorphs like Ice 7, and pressed downward by atmospheres rich in hydrogen or carbon dioxide. These environments mirror the stratified oceans of Ganymede or Callisto, but on planetary scales far exceeding anything within the solar system. Spectroscopy provides the first clues. When a planet passes in front of its star, starlight filters through its atmosphere, leaving imprints of molecules. Water vapor has been detected in several such spectra, not as pools on a surface, but as constituents of an atmosphere in equilibrium with concealed reservoirs. These signatures do not confirm oceans, yet they signal water as a dominant component. Where water vapor exists, the possibility of liquid layers beneath becomes unavoidable. What remains unknown is whether those layers are accessible to energy sources capable of driving chemistry. The tension between detectability and concealment is striking. Exoplanetary science is built on light curves and spectroscopic lines, abstract patterns that suggest hidden mass and composition. The observer never sees the ocean itself, but only distortions in starlight caused by planetary presence. The situation parallels the indirect study of the unconscious mind, which is inferred from slips, symptoms, and behaviors rather than directly apprehended. Oceans beyond the solar system exist, for now, as projections, constructs assembled from absence, uncertainty, and fragments of data. The most unsettling candidates are super-Earths and mini-Neptunes, categories unknown in our own system. Some are thought to carry vast hydrospheres, oceans so deep they would be crushed into high-pressure ices at the base, cutting off contact with any rocky core. Others may straddle thresholds, with hydrogen envelopes maintaining surface oceans under immense pressure. Such conditions defy the anthropocentric image of a shoreline, replacing it with alien configurations in which water exists not as a landscape but as a planetary layer, inseparable from the body itself. The psychological resonance lies in the scale of immersion. Not a pond within the mind, but a mind as pond, identity saturated by water without boundary. Habitability under such extremes is debated. Without rock-water interfaces, energy sources may be limited, yet the potential for chemistry remains, driven by gradients in pressure, temperature, and solute concentration. Life in such oceans, if it exists, would not mirror terrestrial forms, but would exploit conditions alien to human intuition. The very act of imagining such organisms stretches cognition toward domains that resist narrative comfort, reminding us that biology may take paths unrelated to terrestrial precedent. The search for exoplanetary oceans also confronts the issue of scale. A subsurface ocean beneath Europa is a localized reservoir, measurable in hundreds of kilometers. A hydrosphere on a water world may extend thousands of kilometers deep, dwarfing all terrestrial seas combined. The scale alters not only the physics but the psychology of perception. To contemplate a planetary ocean without a seafloor accessible to light or air is to contemplate an abyss without reference, a continuity of water that resists boundaries. Such imagery mirrors states of consciousness described in mystical literature, where the self is dissolved in an undifferentiated expanse, stripped of landmarks, both liberating and disorienting. Observational frontiers continue to expand. Instruments like the James Webb Space Telescope refine spectra, revealing hints of molecules that may coexist with water vapor, methane, carbon dioxide, hydrogen cyanide. These combinations, though ambiguous, suggest active atmospheres interacting with hidden surfaces or oceans. Each detection is provisional, subject to revision, yet each intensifies the sense that beneath the faint signatures lies a reality of oceans extending across interstellar distances. The absence of direct observation sustains attention, knowledge advancing, certainty withheld. Beyond individual planets, the statistical implications are staggering. With hundreds of billions of stars in the galaxy and multiple planets per star, even a small fraction of ocean worlds translates to an uncountable number of concealed seas. If oceans are the rule rather than the exception, then the conditions for chemistry, and possibly biology, may pervade the galaxy. The unsettling aspect is not abundance but invisibility, a cosmos saturated with oceans, none of which can yet be seen. This invisibility echoes the hidden dynamics of the psyche, where processes are everywhere but rarely disclosed, shaping behavior from behind opaque walls. The pursuit of exoplanetary oceans confronts human limits directly. Instruments stretch to detect faint variations in starlight, yet what is revealed are outlines, never interiors. The tension between desire for certainty and resistance of concealment generates an atmosphere of perpetual deferral, where knowledge approaches without closure. It is a rhythm mirrored in both science and psychology, the endless approach to what is hidden, the recognition that every revelation only expands the perimeter of mystery. The recognition of concealed oceans on exoplanets leaves science suspended between knowledge and speculation, between the measurable and the inferred. Each new detection sharpens the sense of vast reservoirs hidden across the galaxy, reservoirs that may persist in silence until instruments sharpen further or encounters become possible. The forward pull lies not in what is confirmed, but in what remains unresolved. Oceans without shorelines, existing at scales and distances that dissolve the familiar categories of perception. Across cultures, epochs, and intellectual traditions, the image of the ocean has served as more than a geographic reality. It has functioned as an archetype, a symbol recurring with such persistence that it appears hardwired into human imagination. In mythologies from Mesopotamia to Polynesia, creation itself emerges from primordial waters. In psychoanalytic thought, Carl Jung treated the sea as a metaphor for the collective unconscious, a depth in which individual boundaries dissolve into a shared substrate of archetypal forms. In both science and symbolism, the ocean represents hiddenness, potentiality, and transformation, qualities that resonate strongly when the focus shifts to seas concealed beneath alien crusts. The persistence of water as an image of origins is not arbitrary. Biochemically, life on Earth arose in aqueous environments, where solvent properties permitted complex molecules to interact, self-assemble, and eventually reproduce. Culturally, this biological fact transmuted into myth: the waters of chaos, the abyss of potential, the womb of gods. To speak of hidden oceans on distant worlds is therefore to reactivate ancient motifs, to place planetary science into continuity with archetypal memory. The unease such discoveries provoke may stem less from their novelty than from their familiarity, the recognition of a symbol resurfacing in empirical data. Psychologically, immersion in water evokes regression, a return to earlier states. Freud associated dreams of submersion with birth, Jung with collective dissolution. Subsurface oceans extend this symbolism into the material cosmos, embodying states that are concealed yet active, inaccessible yet formative. They exist beyond reach, beneath protective shells, much as unconscious processes exist beneath the crust of awareness. Just as those processes may erupt in dreams, symptoms, or behaviors, hidden oceans reveal themselves indirectly through fractures, geysers, or gravitational signatures. The metaphor is not imposed but emerges from structural similarity, layered concealment, occasional leakage, transformative potential. The archetype of the ocean also carries ambivalence. It is both generative and destructive, nurturing and engulfing. Sailors have treated the sea as both provider and predator, yielding fish and trade routes while swallowing ships without trace. In psychological experience, the ocean embodies both maternal protection and annihilating immensity. Subsurface seas carry the same duality. They may host conditions suitable for life, or they may represent sterile immensities that extinguish possibility. The unease arises from the uncertainty, the recognition that what lies beneath could be either sanctuary or abyss. In modern neuroscience, the brain itself has been described with aquatic metaphors: waves of neural oscillation, streams of consciousness, floods of neurotransmitters. These linguistic patterns are not mere ornament. They testify to an enduring tendency to frame hidden complexity in terms of water. The unseen dynamics of cognition, always shifting and difficult to contain, resemble currents more than mechanisms. When planetary scientists speak of circulation in hidden seas, of convection and stratification, they extend a metaphor that has been in use for centuries in describing the psyche itself. The language converges across domains, suggesting that the ocean serves as a bridge concept for thinking the unthinkable. There is also a temporal dimension to the archetype. Oceans signify deep time, persistence beyond human scales. Subsurface oceans may survive for billions of years, insulated from cosmic catastrophes by kilometers of ice. In myth, waters precede creation and remain after destruction. In psychology, the unconscious is timeless, preserving archaic material unaltered by conscious chronology. To confront a planetary ocean hidden in darkness is to confront a temporal depth as well, a reminder that processes may continue independent of surface events, indifferent to human measures of beginning and end. The confrontation with hidden oceans destabilizes the boundary between inner and outer. On Earth, the ocean is an external environment into which one enters. In planetary science, the ocean becomes internal, enclosed within. This inversion mirrors psychological dynamics, where the external world is internalized, and the internal world is projected outward. To study an ocean beneath Europa or Enceladus is simultaneously to study an object and to encounter a symbol, one that reflects back upon the mind that perceives it. The tension lies in the recognition that inquiry is never only about the external. It always resonates with internal archetypes that shape perception. What lingers most forcefully is the sense of incompletion. Oceans, by their nature, resist closure. They cannot be easily circumscribed, their surfaces always shifting, their depths always concealing more than they reveal. The same is true of unconscious processes and of archetypes themselves. They are inexhaustible, offering interpretations but never final resolutions. Each discovery of a hidden ocean adds layers of complexity rather than answers, pushing inquiry deeper into both planetary interiors and human interiors. The persistence of the archetype ensures that the discovery of concealed seas beyond Earth will not only alter scientific models, but will also reverberate psychologically and culturally. Oceans will continue to serve as mirrors in which humanity recognizes both its origins and its uncertainties. The presence of these archetypal waters across planets and moons presses against imagination with the weight of inevitability, suggesting that the cosmos itself may be structured in accordance with patterns the psyche has always intuited. As new instruments probe farther, and as the catalogue of ocean worlds expands, the archetype will grow more insistent, reappearing in new contexts, demanding re-examination of both the cosmos and the mind. Each layer of discovery opens into deeper currents, sustaining a forward momentum that resists resolution, pointing toward further depths that remain submerged beyond reach.